Welcome back. This is lesson 15 in our Python for Beginners series. This is the first of a series of lessons where you'll learn to use loops, and we're going to begin by learning to use what we call counter-controlled loops. In this lesson, we'll look back at what we've learned about program structures. I'll introduce the topic of loops, and we'll look at the different types of loop that there are. We'll learn how to create for loops, and we'll look at variations on the basic for loop. So let's recap what we've learned about program structures. In Python, program structures begin with a header. A header ends in a colon, and that tells Python that the next few lines are the body of the structure. The header controls the structure, and the body is a series of commands that are included within the structure. So the structure that you've learnt so far is the if structure, where the header has a test in it and the commands in the body are carried out if the test is true. Loops also have this familiar header body structure, and the body is indented. The commands in the body are repeated. This is also called iteration. The commands in the header control how many times the repetition occurs. So let's look at some key terms that we'll use when we're working with loops. Each repetition of a loop can also be called an iteration, and this word is quite often used in computer science. When we increase a value, typically this happens inside a loop, we say that we increment the value. We can increment by any number, but if we don't say what the number is, we're usually incrementing by 1. And every loop is controlled by an exit condition, and the exit condition tells us how the loop stops. There are two types of loop, and they're defined because they have different exit conditions. The two types of loop are called a counter-controlled loop and a condition-controlled loop. In this presentation, you'll learn about counter-controlled loops, which I can also call a counter loop. Counter loops always begin with the Python keyword for, and the header is a bit more complicated than an if structure. The keyword for, the name of a counter variable, and then the range that we want it to count up to. So in this example, my counter variable is called counter, and I've told it to count up to 3, and each time to print out the word hello. So if I ran the program, this is what my output would look like. This might be a good point to pause the presentation, open Python if you haven't got it open already, and try just writing this very simple program. You can also put it into the shell and try it there. We often call the variable, the counter variable, by the letter I, a lowercase letter I. That's a bit of a programming convention, so if other programmers look at your code, they'll understand what you mean by I. So the program begins with exactly the same line, but I've changed the variable counter to the variable I. The command inside the loop that's printed out 3 times includes the counter variable. So if we run this program, this is what we'll see. The value of I is printed out each time we go round the loop. You'll notice straight away 2 things about the value of I. One is that the first time round the loop, I has the value 0. That's always the case in Python unless you override the default. So it defaults to 0, and it counts up to 3 but it stops just before it reaches the stop value. So it does loop 3 times, but it isn't counting 1, 2, 3, it's counting 0, 1, 2. So when we create a for loop, we give a stop value. The counter will count from 0 up to 1 before the stop value, like this. Sometimes we don't know in advance how many times we want the loop to repeat. In that case, we could get the user to enter the stop value. So here I have asked the user to input the stop value, converted it to an integer, and then I've told the computer to count up to that stop value. So if I ran the program, in this example, the user has entered the value 5, and so the loop has count up from 0 to 4. So here's an opportunity for you to try writing some simple programs using counter-controlled loops. Here are 4 suggestions, so I suggest that you pause the video, open Python, and write these 4 programs very quickly to show that you understand the topic. So write a program that will output your name 10 times, one that will output the numbers from 0 to 99, and one that will output the numbers from 0 to a value chosen by the user. And finally, see if you can write a program to output the 5 times table. On the next slide, I'm going to show you that. So if you want to prove that you can do it without seeing the answer, have a go now. Press pause. So this program will print the 5 times table from 5 times 0 up to 5 times 12. I can make it a little bit more interesting for the user by adding the full description. So 5 times the number equals and then the value. So it'll go 5 times 0 is 0, 5 times 1 is 5, and so on. Can you remember why I've put it up to range 13 rather than range 12? That's because the program always stops 1 before the stop value. So it will stop at 5 times 12, which is what we normally write when we're doing a 5 times table. There are some variations in how we set the range for a counter-controlled loop. For example, if you look at the code on the right, instead of just setting the stop value for a range, we can set the start value. If we don't set a start value, it defaults to 0. But in this example, I've set a start value of 10, and it will count up from 10 to 19 and then stop, because 20 is the stop value. I can also tell the computer what increment value to use, and in that case I have to give 3 values: the start value, the stop value, and the increment value. So in this example, the computer will count up from 10 to 19 in steps of 2. So it'll go 10, 12, 14, 16, 18, and then stop, because the next iteration would take it past the stop value. So do try these and you'll see that it will print out just in the correct way. And we can also make the computer count backwards, and sometimes that is what we want to do. So here I've asked the computer to count from 10 down to 5 in increments of -1. So it will go 10, 9, 8, 7, 6. Again, this can be useful for some tasks that we want to do. So be aware of those variants. You can give 1 value, and that would be the stop value. You can give 2 values, that would be the start and stop value. Or you can give 3 values, and that would be start, stop, and increment. So to recap, in this lesson, you've learned what a loop is. You've learned about the 2 types of loop, which are defined by different exit conditions. You've seen how to create a program that uses a counter-controlled loop, and you've learned how you can vary the counter range and the increment. So here are 3 exercises that will give you a chance to practice your skills with counter-controlled loops. Firstly, write a program where the user enters 10 numbers, and for each number a message will appear stating whether that number is an odd or an even number. Secondly, create a program that will output any times table. So if you say the 11 times table, it will print out the 11 times table. And adapt that program, if you have time, so that you choose the start and stop values for that times table. For example, you might want to begin at 11 times 20 and finish at 11 times 30. So try those. They all use skills that you've already had a go at during this presentation. In the next lesson, we'll look at the other sort of loop, which is called a condition controlled loop. So see you then.